Right. So let's start the lesson. Last day we discussed up to this model how to iterate a function of the form a sine division. On top you have a sine x plus b cos x divided by b sine x plus q cos x. Right, this model we have done last day. Our method is just to remind you, the method is we express the numerator in the form lambda times lambda times the denominator plus some constant, another constant mu times derivative of the denominator. Express express it in these forms, then find lambda and mu, and that's what we do to integrate this type of a function, right? And today we are going to learn like the most important method, or we say a very important method used in integration, right? Which is called product method. Right. This method is called integration by parts. Integration by parts, right? This is a very important method in the exam. Like they always ask apart from integration by parts. Usually the integration question consists of three or four parts. One from mostly from rational functions to find partial fractions, and then use partial fractions to integrate. Then second part mostly from this integration by parts, and the third mostly from the next topic. No, the last topic we are taking, that's definite integration, right? Uh, so integration by parts always in your paper. Integration by parts. What is this? If you remember, so far we have converted. Good evening, Litmal. So far we have converted several theorems or rules that we learned in differentiation into rules of integration, right? Several rules. Good evening, Abhita. Like in differentiation, we have a rule d by dx of lambda y equals lambda dy by dx. Like you can take the constant out. So we converted this back to a rule of integration, saying integral of lambda fx dx. Using this, we derive this rule equals lambda times fx dx. Right? This rule is used for that. Then we learn another rule in differentiation: d by dx u plus v, addition of two functions, is equal to du by dx plus dv by dx. Right? We using this, we derive a rule for integration which says integral of fx plus dx is equal to, you can break it into two parts, integral of fx dx plus integral of dx. Similarly, if it is the subtraction here, you will subtract it here in differentiation. In integration also, if it is subtraction here, you will subtract it here. Including these rules, several other we have converted into rules of integration. So we have now in this like operations of functions, we have two more rules. We have seen two more rules in differentiation: the product rule and the division rule. Product rule says this is equal to. Product rule. What is it? Yeah. U dv by dx plus product rule is u dv by dx plus v du by dx. The division rule is bit more complicated. D square here, v du by dx minus u dv by dx. But these rules, the last two, we haven't seen yet in integration. Alright. Now today we are going to connect this, the product rule of differentiation with integration, right? And using this rule, we are going to derive a formula, something like a formula, which we are going to use to integrate some functions. Okay. Right. Consider two functions u comma v of x. Then we have the product rule of differentiation, which says this is equal to u dv by dx plus v du by dx. Right? So now I will make this the subject, one of them, mostly this. U dv, making this the subject, u dv by dx equals this taken to the other side, d by dx uv minus goes to the other side, d du by dx. Right? Making this a subject. Now I am going to integrate either side with respect to x. Okay? Integrating either side with respect to x. You get integral of left hand side u dv by dx equals integral of this, integral of d by dx uv minus integral of v du by dx. Right? This one get there should be dx here. Integral of v du by dx. Right? Now look at this middle term. Right. Look at this middle term. Look at this middle term. Here you have a function uv. uv, you first differentiate with respect to x, then again integrate it with respect to x. What happens? uv product differentiated with respect to x, then again you integrate with respect to x. So So what happens there? Good. Maganda UV product first differentiated with respect to x, then you integrate it with respect to x again. Finally, yeah, UV, no, plus C we don't need. Just say UV for the moment. UV, again a function, right? Some function. UV plus C we will add at the last step. It's correct with Mal anyway. It's UV. Differentiation and integration. Good evening, Sachin. We identify differentiation and integration like the reverse operation, inverse operation of each other. You think differentiation, you send it to this side, integrating, you take it back to where it was. So this gives just UV. So U dV by dx equals, this gives UV minus integral of b du by dx. Right. So this is the all important result that we were looking for. We were searching for this. Hereafter, it will be used as a formula to integrate some functions, right? In some modules, this is very helpful, and you call this the formula of integration by parts, right? This is called the integration by the formula of integration by parts, right? And now the second question, in what situations we are going to use it, right? There are basically three places we use this formula, integration by parts, right? We'll write them. This is used to integrate to say solve problems like in cases. Now look at this. This formula is used to find this. Find this side, we will use the other side. That's what always a formula does, right? So this side, u into dv by dx. U is some function of x, dv by dx again a function of x. So it looks product of two functions of x. So this is one occasion where we use integration by parts to integrate a product of two functions, right? A product of two functions, but the thing is, product of two functions, if it looks like x into x cubed minus 1, do we need to use this? X into x cubed minus 1, do we need? No, you just expand it. That will give x4, x to the power 4 minus x. In 1 second, you can finish it. Integration. So, even though it's a product, you don't need to use integration by parts. or something like this, say sine 3x cos 4x 3x. Do we need integration by part? It's again a product, right? Sine and cos product. Still, you don't need, because we have integrated this at the very beginning, maybe the first day, very first day that we started integration. Uh, for this, you can use formula, trig formula. You can convert it into an addition. This looks a product, but with the little simplification, you can convert it into an difference, or an addition or difference, right? So the thing is, these are similar type of product functions. An algebraic function, algebraic function multiplied by another algebraic function. Here, a trig function multiplied by another trig function. If they are a similar type of functions, we have ways of simplifying them. For this, you can use the formula, right? But the thing is, if you have something like this, x dx, dx, or maybe ex sin x, can you simplify them using formula or normal algebra? No. So they are like two different type of functions: algebraic function and ex, trig function and ex, right? So in a case like this, two different type of functions multiply and to integrate, right? So you can do them like this. So in cases like this, we need this formula, integration by parts. That's one occasion where where we use integration by parts. That's number one. To integrate a product of two different type functions. To solve uh, integrate a different type of functions. Example, like x e x dx, or it can be x sin x dx, or it can be ex sin x. Two different type of functions multiplied, right? So to integrate, you have to use this, right? That's one occasion. Number two, you use this formula, integration by parts, to integrate inverse functions also. Sine inverse, cos inverse, tan inverse, ln, those inverse functions. To integrate inverse functions. So looks like integral of sine inverse x, integral of tan inverse x, integral of ln x. Right, likewise. That's another occasion where you use integration by parts. Apparently, it's not a product. Yes, just tan inverse x plus ln x. There can even be a product, but even without that, we use integration by parts. Right? You will see how to apply this here. Number three, another special case. Do you remember at the very beginning we said, maybe this in the second lesson, uh, a special case we made to integrate sec x. To integrate sec x, we have a special method. Remember? To integrate sec x, I taught you the method and told that you can't forget it, because you need that method to integrate sec x. You can't do anything else. You have to remember that. If asked to integrate, the method you should remember, there's no other way to apply. මොකද කියන්නේ? මතකද? To integrate sec x, there's a special method. බුදුන් මේ මෙච්චර ගණන් yeah. අභීත. Yeah. Multiply and divide by sec x plus tan x. මතක තියෙනවනේ. Sec x plus tan x. Right. That is for sec x, and also for cosec x. Similarly, you multiply and divide by cosec x plus cot x, right? And now sec cube and cosec cube functions, right? To integrate them, you have to use integration by parts. There is no other way, right? If asked sec cube or cosec cube, you should remember that it is integration by parts. You integrate it by parts, right? Another special case, to integrate sec cube x, cosec cube x, etc., or sec to the power 5x, sec to the power 5x. These are special cases, very special things in integration, right? Special methods. මතක් වෙන්න ඕනේ. කියන්නේ ඕගොල්ලෝ ඒ වෙලාවට මොනවද දැඟලුවත් ගන්න කරගන්න බෑ. හරියට මේකම මතක් වෙන්නේ නැහැ. හරි? ඔය ටික තියා තේරුණානේ? වැඩි තේරෙන්නේ නැතුව ඇති. How to apply this? But at least where to apply this, you got some idea, and how we derive that, right? So with examples, some examples, you will see how we apply it, right? Then to ලියාගෙන ඉවරද ළමයි? ඉවර නම් කියන්න. ලියාගෙන ඉවර නම් කියන්න. Okay. Kena call video aku bilang. Finished. Abhi okay, let's see. Kita dalam ini, no? Kami tak kita makan. This is a very important method, and we have to do several examples to take how we try this. Example 1. We have to do examples for all the types. Example 1. Number 1, x, ex, dx. Right? This is a very simple example. Right, now we are going to use the formula to integrate this. To use the formula, we have to match this with this and identify things properly. Right? So one of these you have to take as u. The other you have to take as dv by dx. Okay? One of these you have to take as u. The other you have to identify as dv by dx. So there are two ways. You can take this as u, this as dv by dx, or this as dv by dx, and this as u. There are two options. Kamathi komada? Kamathi විදිය කියන්නකෝ. ඕගොල්ලෝ දැන් විදිය බලන්නත් බෑ. කවුද ඉන්නේ? අභීත ඉන්නවා, සචින් ඉන්නවා නේද? කවුද? රික්මල් ඉන්නවා, තවත් කවුරු හරි ඉන්නවා. Kaun Gamati, what do you like to take as u? What do you like to take as dv by dx? What am I doing? U is first is u, next is dv by dx. U is x. Right? U equals x ලික්මල්. අපි හිත කියන්නේ අනිත් පැත්ත. හරි. දැන්ට ලික්මල් කියන විදිහට ගමු. මෙතන ඉන්නවා කවිෂා. කවිෂාත් කැමති u equals x. ඊට පස්සේ බලමු අභීත කියන විදිහට කරොත් මොකද වෙන්නේ කියලා. අපි දෙවිදියෙන් බලමු. හරි. So anyway there are two options. So let's take this as Kavisha wishes. Take this as u and this as dv by dx. Right? Then I got a computer over there. Right. So let u be equal to x, dv by dx be equal to ex. Right? Then we are going to substitute in this. This is u, this is dv by dx. So to substitute in this, we need u, we have it, right? And we need v. Instead, we have dv by dx. We have to find v from this, right? Further in that, again we need v, and also we need du by dx. Okay? So to substitute in this, we need du by dx and v. So du by dx means the derivative of this. So we have to differentiate this and find du by dx. V means the, what is v? V is the integral of this. V is the integral of this. Du by dx is the derivative of this. We need to find them to substitute in the formula. Okay? Then du by dx is equal to, differentiate this, you can just 1. And v is equal to, it's the integral of this. Integrating ex, you get ex. Okay. Now we have everything we need. Just write down the formula and substitute. I'll write it here. Right. Now we write the formula u dv by d, integral of u dv by dx dx equals ub minus integral of v du by dx dx. Okay? U dv by dx is of course x dx. The left hand side is x dx dx, u dv by dx, u dv by dx, because x dx, x dx, dx, uv, u is this, x, v is ex, minus integral of v, minus integral of v is ex, then du by dx. Du by dx is 1 dx. That's what you get integrating, substituting in the formula, right? So this is equal to x dx is there minus just dx multiplied by 1 is ex dx. Integrating this, you get only ex, and here we write plus c, right? Plus c, so that's the answer. You get the answer, right? Ex, simplifying a bit, taking ex out, x minus 1 plus c. Finally, that's the answer. So to integrate this, we can use the formula and get the answer. Looks very easy, right? But there's another another idea. Abhita says, what if we take u equals gx? එහෙමත් කරලා බලමු මොකද වෙන්නේ කියලා. Something very important in using the integration by formula. This is the thing. When you use this formula, this is a very important thing. Once you apply this method, right? When you use the formula, integration by parts, you don't get the answer at once. Using the formula, you don't come up with the answer at once. Instead, you get another integral here. You want to find this. Applying the formula, you have to find another integral on the other side. So what is this side? The right-hand side integral is much more complicated than the left-hand side. The integral on the left-hand side. Apply the formula, if you get on right-hand side a much more complicated one than what you have on left-hand side, that means it fails. No point of doing it so. Applying it that way, right? This to be meaningful, applying the formula to be meaningful, the right-hand side, what you are getting on right-hand side should be at least not more complicated than what you have in the left-hand side. නැත්තම් කියන්න වෙන්නේ කවදාද දෙවෙනි රාජ්‍ය සිංහ රජුගේ කිව්වේ පාඩම් කරා ඉතිහාසෙ මොකද්ද දෙවෙනි රාජ්‍ය සිංහ රජුගේ කිව්වේ නේද තුඩු දීදී එන්නගෙන සම්දේශය තමයි මොකද කිව්වේ ගුරු දී මිරිස් ගත්තාසේ වෙනවා නේද නැත්තම් ගුරු දී මිරිස් ගත්තාසේ වෙනවා අපි බලමු එහෙම වෙනවද නැද්ද. Okay, now let's start. So this is successful. We started this way. It's successful because we got the answer, right? Now let's try it the other way around and see what happens. Note, in above example, we could have we could choose u and dv by dx the other way around also. The other way around also, right? Like that is, so let's do it. That is, you have to integrate. You have to integrate x ex dx, right? This is the problem to solve. This time you are taking, switching them. This is your dv by dx and this is your u. So let u be equal to ex and dv equal to dv by dx be equal to dx. So then you get, so you need du by dx, which will be equal to apply the formula, you need du by dx and b also. Du by dx මොකද වෙන්නේ? Differentiating ex, you get ex. What about v? Sorry, v by dx equals x, right? dv by dx x, then v will be equal to v is the integral of this. Integrating x, it is x squared over 2. X squared over 2. Now let's write down the formula and substitute in that. dv by dx equals uv minus integral of v du by dx dx, right? So it is x dx equals uv. U is ex, v x squared over 2 minus v x squared over 2 du by dx, it is ex minus x squared over 2 ex dx. මොකද වෙන්නේ? You are asked to find x dx, right? And you use the formula, apply the formula, which gives x squared dx to find. May thinking, why you lazy for you? Yeah, of course, it's the left hand side one. So, in other words, we get a more complicated one. So, what that updated? If you choose things this way, so that is make things much more complicated. In fact, it just terminates there. Okay, now here, right? So, taking things this way, you can't integrate the function using the formula, integration by parts. It doesn't work here, right? It doesn't work here if you take things this way. So, the lesson we are learning, if you have to apply integration by parts formula, you have to select u and dv by dx, but you have to do it properly, carefully. If you took it wrong way, things will get more complicated. So it will stop at some point. But it's not hard. It's something very easy. So you take u as x, du by dx is just 1. What you have to substitute here is 1. It's very simple. It looks it's going to be simpler than what you have on left hand side. This remain invariant. dv by dx is ex. Then v, what you are substituting here is the same ex. It's certainly not going to be more complicated than the left hand side. And මෙහෙම ගත්තොත් u is ex, du by dx is same ex. So this side remains the same, but your dv by dx is x and v is x squared over 2. What you are going to substitute for v? What you are going to substitute for v is more complicated. Value ගන්න මට පේනවා වැඩි කරදර වුණා කියලා. ඒතකොට එහෙනම් මට ඕනනම් ටේබල් එක කොහොමද දෙන්න පුළුවන් මෙහෙමවත් මෙහෙම ගන්න මෙහෙමවත් මෙහෙම ගන්න. එහෙම නිදි කියලා දෙන්න ළමයි හිතලා බලලා වැඩ කරන්නේ නැහැ කියලා කරන්න බෑ කියලා හිතුනොත් මෙහෙම ටේබල් දෙන්න. ඔක හිතලා බලලා වැඩ කරන්න පුළුවන් නේ. ඒ නිසා මම එහෙම දෙන්නේ නැහැ උදේ කඩපාඩම් කරන්න ඕනේ නැහැ. හිතලා කරන්න පොඩ්ඩක් මොලේ පාවිච්චි කරන්න. ඉඳලා ඉක්ලාරින් මොලේ පාවිච්චි කරන්න බෑ. නැත්නම් මල කරා ඈ මොකද්ද දිග ප්‍රශ්න? They told us to use late method. Situmya, the second method. Dia මොකද? නෑ මොනවත් methods ඕනේ නෑ ළමයි. හරි? කිසිම දෙයක් පාඩම් කරන්න ඕනේ නෑ. මම ඔයගොල්ලන්ට එහෙම කිසිම දෙයක් දෙන්නේ නෑ. මම හැමදාම ඔයගොල්ලන්ට උගන්වන්නේ ඔයගොල්ලෝ මොලේ තියෙන ළමයි කියලා හිතාගෙන උන්දේ අමු මැට්ටෝ කියලා හිතාගෙන නෙමෙයි. බැලු බැලමට පේනවනේ ළමයෝ මෙහෙම ගත්තොත් මේක දුර යනවා කියලා. right? ඒව අමතක කරන්න ළමයි. ඕනේ නැහැ. මොකුත් ඕනේ නැහැ. මම ඔයගොල්ලන්ට පුළුවන් තරම් අඩුවෙන් මතක තියාගන්න උගන්වන්නේ හැමදාම. මේ මෙතඩ්ස් උනත් මම ඉන්ටිග්‍රේෂන් මෙතඩ්ස් අඩුවෙන් උගන්වන්නේ. ගොඩාක් දේවල් ගොඩ ගැහුවම ඒ වෙලාවට තේරෙනවා හරි ෂෝක් එකකට. විභාගයට ගියාම ඔක්කොම කන්ෆියුස් වෙනවා. හරි ඔළුව ඇතුලේ එහෙම මේ ෂෝට් වෙන්න ගන්නවා. ඕනේ නැහැ. ඔයගොල්ලන් තමන්ගේ බුද්ධියෙන් කරන්න පුළුවන් දේවල් මෙහෙම කරන්න. එතකොට ඒවට කිසිම උදව්වක් ගන්න එපා. තමන්ට කරන්න පුළුවන් ඒවට. හරි? ඕනේ නැහැ. මොකුත් ඕනේ නැහැ මතක තියාගන්න. හරි? මම එහෙම දෙන්නේ නැහැ. මේක ඕඩ මැට්ටෙට තේරෙන්නේ නැත මෙහෙම ගත්ත හැටි. වැඩි අවුල් වෙනවා කියලා. ආයෙ මොනවාට කටපාඩම් කරන්නේ. ඔයගොල්ලෝ තමන් ගැන විශ්වාසය තියාගන්න ළමයි අවශ්‍ය නැහැ. හරි? මම හැමතිස්සෙම උගන්වන්නේ ඔයගොල්ලන්ට පුළුවන් තරම් ඔයගොල්ලෝ තමන් ගැන විශ්වාසය තියලා විභාගයට යවන්න. නිකන් ඒලා ටිකලා ගන්න. You don't need any, right? Okay, so we write a note. So this gets more complicated. This is more complicated than what you have in left hand side. Therefore, one has to be careful. You have to be little careful selecting u and dv by dx. When I'm good known, right? Selecting u and dv. මට ඕන table එකක් දෙන්නත් පුළුවන් එහෙම ඕනේ නැහැ. හරි? Right. Okay, after that we can go to more examples. Just remember that you have to take them properly. That's all. මම ගණන් දෙක තුනක් දානවා හදන්න. කටපාඩම් කරන්න එපා හොඳේ. විභාගෙට ගිහිල්ලා ඔය අකුරු දෙක අමාරු වුණොත් එහෙම ඔක්කොම ඉන්නේ. නේද? ඒ විභාගේ වෙලාවේදී ඒ පැය තුනේදී අවුල් වෙන්නේ නැති වෙන විදිහට ඉන්න ඕනේ. පුළුවන් තරම්. කරගෙන යන්නකෝ. කරගෙන යන්න මම වෙලා දෙන්නම්. ඔකල කරන්න දන්නේ පළවෙනි කර. This one finish. This is u dv by dx. Equals e over 3. Write down the formula. D minus E W 3x minus 1 plus C. This is the answer for the first part. You can take E3x over 9 out. So that gives 3x minus 1. Okay. Yeah. Certificate. You can check your answer for number 2. If correct, then go to number 3. Number 3. Correct na? Ero una ke tane. Em itu anne. Itan taam balan ek ape nodanne එකක්ද කියලා. Blood ගොඩක් ඉන්න මම plan out කරනවා එන්න මේ කියන්නේ දැන් බලන්න කොහොමද කියලා සිතුම්යා මම මේ මොනවද වෙන්දට මගේ රවුටරේ තියලා තින්නේ අපේ ගෙදර පවර්ෆුල්ම සිග්නල් තියෙන තැන. අද ගේ ඇතුලේ වැඩක් නිසා මම මෙතනින් තියාගත්තා. that can be the reason. මෙතන නෙමෙයි හොඳම තැන මේක තියන්න. ගේ ඇතුලේ පොඩි වැඩක් ඒ නිසා මම මෙහෙට ගත්තා ඒක. ඕගොල්ලන්ගේ ගෙදර චෙක් කරලා තනින් තන එක තැනක් අහු වෙනවා. එතන තමයි හොඳම. router එක තියන්න. දැන් අද මම තියලා තියෙන්නේ හොඳම තැන නෙමෙයි. But still this is a very powerful thing. ඒ තරම් ප්‍රශ්නයක් නැහැ. Okay. Oh, sir. So you go to the third rather. If answer for this is correct, then go to the third. ටිකක් කළා යනකොට හරියයි කොහොමද? මේ සිග්නල් එහාට මෙහාට එනවා. Dia barang-barang begini. Hidungnya itu. You apply it again. That's why we say by parts, part by part. I'll let you know. You can take 2 out and it gives x dx dx. Did you come up to this in the third? Hmm? If you came up to this and now thinking and thinking how to integrate this. Hmm? Uh-huh. So the solution is on the other page. It is one page away. This is what we discussed earlier. Our litmus. To integrate this, so that's the first example we have taken. That means you have to use, to integrate this, you have to use integration by parts again. Make a venom man, find it separately, and then substitute. Hmm? You have to find xcx, right? Apply the formula again. You do it, then see. Hmm? Ini tuh caranya tuh, dari gimana? Mana? Coba. So apply it again. Applying it again, and this is taken as u, this is as dv by dx. So du by dx is equal to 1, v is equal to dx. You have seen this earlier. So x dx dx. We have written the formula once. You don't need to write it again. We have written it once. You got to come on, the formula. I thought of one again. uv, that's 1 into x dx minus dx into 1 dx. So it's x dx minus dx, right? We don't write plus c here because plus c. So we can substitute it here. This part we found again using by parts. Substituting 1, substituting in 1, you get integral of x squared dx dx equals x squared dx minus 2 times this part we found separately, that's x dx minus dx. Method plus c and method you have multiplied by plus c finally. It's enough you write one constant at the end. So take ex out. Ex is common, you can take it out. So that will be equal to x squared minus 2x plus 2 plus c. When उत्तर आते हैं आता इलाके का ध्यान है then टिकट वेटिंग करना ना. Now you have some idea what we are doing here. The third, no, rather the fourth. Then वेटिंग करेंगे ना number 4. Okay, after that, you can check the first step, right? Applying the formula once, this is what you get. And now to find this, you would apply it again. Hari කරගෙන යන්න. ඉවර කරා? කරගෙන යන්න මම ඔයගොල්ලන්ට තව වෙලා දෙන්නම්. ටිකක් වේගෙන් කරන්න ඕන ළමයි. You need a good practice. First step, this first step, then continue. මේක simplify කරන්න තව step එකක්. After this, this one you get the second step. Mistake? This one. This one. Be careful. So we can take finally e 3x over can't we take 27 also? 1 over 27. They'll give 9 times 2x minus 1 squared minus 12, no, yes, 12 times 2x minus 1 minus 1 plus 8. චුට්ටක් සිම්ප්ලිෆයි කරන්න පුළුවන් නේද? මොනවද එන්නේ බලන්න. 1/27 E3x x items මොකද වෙන්නේ 4 29 36 36x square මෙතන එනවා -4 -36x minus 24 minus 60x minus 60x and the constant plus 9 plus 12 and plus 8 plus 20 plus 29. Finally, this is what I get plus 29 plus c. Don't forget to write plus c. This is my final answer. 1/27 e3x into 36x squared minus 60x plus 29. Agree? මොකද උනේ? මේ උත්තරය ආවද ළමයි? මේක ආවද? අපි ඉතට ආවා කියනවා උත්තරේ. මොකද කියන්නේ අනිත් අය? You are taking e to the power 3x divided by 27 out. Then it's 36x squared minus 60x plus 29. අපි ඉත උත්තරය ආවා කිව්වා මොකෝ අනිත් අය? අනාගෙන ඉන්න වැඩි. සිතුම්යා හරි. ඒ කියන්නේ මම හරි කියන එක නේද? මගේ උත්තරේ හරි කියන්නේ. මෙතනත් එක්කෙනෙක් ඉන්නවා මම හරි කිව්වා. Okay, then you can go to the next. ඉක්මනින් කරගෙන යන්න. right? වැරදුනක් තමක් නෑ කරගෙන. Six එන්නේ නෑ. 6ට 60ද? සිතුම්යා 606. This is 60, right? මෙතන එනවා 9. What's that? මෙතන එනවා minus 36x. මෙතන එනවා minus 36x minus 24x. 6 or 60? Situmya, you mean? Six question එක පේන්නේ නැහැ කියලාද? හරි මම දන්නවා. හරි. මම කරගෙන යන්න පුළුවන් දෙයක් කරන්නකෝ. පුළුවන් දෙයක් කරන්න ඉස්සෙල්ලා. No problem. This is the answer for the fifth, right? Take a lazy. Minus x cos x plus sin x plus c. හයවෙනි එක බලන්න ඉස්සෙල්ලා පුළුවන් දෙයක් කරන්න. Apa tu ni? Grade එකක් ගේන්නද? සිතුම්යා grade එකක් ගේන්නද? එරිලා දින්නේ. බලාගන්න. Right, number 6. Dx sin x. Yeah, you have to take one of them as u, the other as dv by dx. Which way you have selected? U is dx, sin x. What is your u? If you take u equals your sin, sin x, then du by dx is cos x. When else not? Sin x cos x, much harder or easier? Sin x, instead of sin x, you get cos x. As you take u equals ex. No, hari bala. Then you take dv by dx equals ex. Then v is ex. If you take u equals ex, then du by dx will be ex. වෙනසක් වෙනවද? කොයි පැත්තට ගත්තත් වෙනසක් වෙනවද? So you take u equals ex, dv by dx equals sin x. If you take this way, then du by dx will be equal to again ex, v will be equal to minus cos x. You take it the other way around, u equals sin x. If you have taken it the other way around, dv by dx equals ex, then du by dx will be equal to cos x, and v will be equal to again ex. වෙනසක් වෙනවද? කොයි පැත්ත ගත්තත් එකයි. එහෙනම් කැමති එකක් ගන්න. No problem. තේරුණාද සිතුම්යා? කටපාඩම් කරන්න ඕනේ නැහැ කිව්ව එකක් නෑ. මෙතනදී කොහොම ගත්තත් එකයි. right? දැන් කොයි පැත්තම ගන්නවද? මම මේක ගන්න. කොයි එකත් එකයි ඈ. This is u and this is dv by dx. කොහොම ගත්තත් එකයි ඈ. Let u be equal to ex, dv by dx equals sin x. Then du by dx will be equal to ex, v will be equal to minus cos x. ඔකොල අනිත් පැත්තට අරන් තියනවා නම් කමක් නැහැ වෙනස් කරන්න එපා. එහෙම කරගෙන යන්න. right? අනිත් පැත්තට ගත්තා නම් එහෙම කරගෙන යන්න no problem. UV and plus you came up to this ළමයි everybody came up to this ඊට පස්සේ දරස්කාර බ්‍රේක් ගහලා නැවතුණා තාත්තේ හපනවා වෙනව තුණා don't know how to proceed. The thing is no other option. No other option. You have to apply it again. But there's one thing to that you have to be careful. Once you apply it again to this, that I mean in this, if you apply it again in this, uh, one thing you have to be careful. Take it the same way as you have done it here. Now at this stage, Situmya, how the Abhita, if you now at this stage, what if you take them the other way around? Now switch. Here your u is ex, dv by dx is sin x. If you take u equals now cos x and dv by dx equals ex, මොකද වෙන්නේ? If you move the reverse way, ආපස්සට යනවනේ. ආපස්සට ගිහලා මොකද වෙන්නේ? ලස්සනට ඔක්කොම කැපිලා ගිහිල්ලා finally you get 0 equals 0. Finally you get 0 equals 0. ඒක දාවේ සිතුම්ය. A very nice result. 0, everything get cancelled and you get 0 equals 0. එහෙම දුන්නේ සිතුම්ය. ඉවර නැහැ. කො අනිත අභීත ඉන්නවා කවුද ලිත්මල් ඉන්නවා. So you have to be careful in that, right? In this type of a problem, you in the second step you have to take the same way. You have to select u and dv by dx the same way as you have done in step 1. Okay, now to find ex cos x dx. Now take this again as u. This is u and this is dv by dx. Let u be equal to ex, dv by dx be equal to cos x. Then du by dx will be equal to ex, dv be equal to sin x. කරගෙන යන්නකො. මම විනාඩි දෙකක් දෙන්නම් කරගෙන යන්න. ඔව් ඒක එනවා. ඉතින් දැන් පොඩ්ඩක් කල්පනා කරන්න මොකද කරන්න කියලා. අර කැරකිලා මුලට ආවද ආපහු දැම්මොත් ආයෙකට දැම්මොත් මේකයි ආපහු දැම්මොත් ඒකයි සංසාරේ ඉන්නකම් ගාන හදා දින්න වෙයිද? සිතුම්යා ඒක දැම්මම මේක එනවා මේක දැම්මම මේක එනවා. එහෙමද? ඕකෝනේ ඉතින් හැම සංසාරේ ඉන්නකම් ගාන හදා දින්න පුළුවන්. ආයතනයක් දානවා integration by parts, then you get ex cos x, then apply again you get ex sin x. එහෙමද යන්නේ? Oh, now check it very carefully. Check what you have got by now very carefully. Now substitute this in 1 for ex cos x. You substitute here and see what happens. Substituting in 1, you get integral of ex sin x dx equals minus ex cos x plus ex sin x minus, again you get ex sin x dx. Oh, that's what you are saying, Situmya. Still you don't get an idea? හොඳට ඇස්සල්ලා බලන්න. නැත්නම් කන්නඩි දෙක දාලා බලන්න. Once you got up to this, what's the next step? It's a very simple thing to do. බලාගන්න හැමෝම. If you have come up to this, the next step, very easy. You should have seen this. Send this to the other side. It will be doubled. This will be doubled. So 2 times integral of ex sin x dx. From the right hand side, you can take ex out. That will give you sin x minus cos x. And finally, what do you do to get the answer? Just divide by 2. That's all you have to do. Are you there? Just divide by 2. So integral of ex sin x dx equals half ex sin x minus cos x. Don't forget to write plus c on the side. ළමයි අද මේ පාඩම ඉවර කරන්න ඕන. ටිකක් වෙලා ගියත් මම කරනවා ඉවර වෙනකම්. තව ගණන් දෙකයි හදන්න තියෙන්නේ. Number 7. Integral of ln x dx. අපිට වැඩි වෙලා යන එකක් නෑ. Integral of ln x dx. ඔක තේරුණා නේද ළමයි? Number 6. How we finish it finally. තේරුණාද? What we have done finally in number 6. සටින්ගේ නම දැක්කේ නෑ. මොකද නින්ද ගිල්ලද? මුලින් දැක්කා ඊට පස්සේ දැක්කේ නෑ. ඉස්මල් හරි. තව කවුද එක්කෙනෙක් දෙන්නෙක් ඉන්නවා? Okay. Okay, ලියාගෙන ඉවර කරන්න number 6. Then we can go to number 7. Number 7. In number 7, I'll explain something. I have to explain something. Let's finish it. What is it in number 7? The 6 examples we have done so far. Do you remember at the beginning I said Sachin ඉන්නව නේද? හොඳයි. මං හිතුවා නින්ද ගියා කියලා. Right. At the very beginning we said there are 3 occasions where we apply integration by parts, the formula, right? The 6 examples we have done so far are under the first to integrate a product of 2 different type of functions. All the examples we have done so far are under that. Now this is right. Very good. Okay. Now this is under what? That's the second application to integrate inverse functions. So now look at this. Do you see any difference in this? Something different to the previous things? We said we have to apply integration by parts, right? But to apply integration by parts, you need the formula, you need a product. But do you see a product here? Hmm? Yeah, only one function, Situmya. Correct. So that is the problem. But now you have to find a solution for that. Ekat kiyan. If you have seen the problem, now give a solution also. To integrate this, so we have ln x, just ln x. Now we said that to integrate functions like this, we have to apply integration by parts. But to apply integration by parts, you need a product. So there is no product here. Now you have to make it a product, but in the process you can't like deface it. විකෘති කරන්නත් බෑ. විකෘති කරන්නත් බෑ. වෙනස් කරන්නත් ඕනේ. What do you do? Yeah. By something, multiply divided by something. Something like any idea or anything? You have to make it a product, but you can't deface it. Yeah, multiply by 1. So it won't change. Yes, Situmya, it's correct. Multiply by 1. We write it as, or we make it looks a product. Looking at a product by multiplying by 1. So ln x dx is equal to 1 into ln x dx. That's one thing you should remember. And Abit, right with dx. Ek hariyan nahe Abit. Situmya adhas hari. So we have written this as a product. So here it is as a product, right? Now එක කඩුල්ලක් වෙන්න. Now the second head. So you have to now decide what is u, what is dv by dx. ඒකට උත්තර කියන්න ටක් ගාලා. But you take as u. Now we are going to apply integration by parts because we have a product here. What is your u? What is dv by dx? U is 1. dv by dx is, and naturally ln x. U equals ln x. Situmya කියන්නේ. අපි ගත්තොත් u equals 1, dv by dx equals ln x. Then du by dx will be equal to differentiating 0. It will disappear. On the other hand, v will be equal to लिखमल क्या नहीं u equals ln x. Yes, du by dx will be equal to 0 and v will be equal to integral of ln x. ඒක දන්නවා නේද? මේක කරන්නේ නේද? ඒකනේ අපිට තියෙන ප්‍රශ්නේ. So දැකනේ සිතුම්ය මම කිව්වේ කටපාඩම් කරන්න ඕනේ නැහැ. You have to think logically. So certainly It's not going to work. You can see it at once. So it has to be the other way around. Okay, that's all I'm saying. You take this as, this is the only option, right? This as q and this as dv by dx. And finally, I will number 8 to integrate sec cube bits. So usually this is how you integrate inverse functions, right? අපිට වෙලා තිබුණොත් මට මේක කතා කරන්න ඕන විශේෂයෙන් මේක ඇතිනේ තව ටියුට් එක ගණන් ඇති මේක ඉවර කරන්න then you can go to this, right? Sec cube x dx. this one. Usual. Betul? UV to next. This is 1. And then next differentiating, you get 1 over x. And v equals x. Integrating 1, you get x. Okay, then substituting, write the formula and substitute. So ln x dx equals uv x ln x minus integral of v into 1 over x dx. Hmm? 1 into dx. Now integrating this, what is it? Integral of dx is x. You can take x out, it will be ln x minus 1 plus c. Correct? Right. So that's how you integrate inverse functions. චුට්ටක් මතක තියාගන්න. හරි? You have to write it as 1 into the inverse function. හරි. අන්තිමට මේක try කරන්න. මම වෙලා දෙන්නම්. Now wait. This is a very special one, right? Secure. So you have to follow this method. You have to follow this method strictly. If not, you will never be able to integrate it. So you have to remember it. Try this. වෙලා දෙන්නම් විනාඩි දෙකක් තුනක් try කරන්න. Number 8. කරුවක් දාලා ලියාගන්න. මේ මතක තියෙන්න ඕනේ. The last example, බඩගිනි නියම තියෙනවා නම් ඉක්මනින් කරන්න. ගෙදරින් දැන් කපා විවිනේ නේද ඉගෙන ගන්න. බඩගිනි. මෙයාට නම් බඩගිනි. අමාරු නෑ මම වෙන්න ගන්නවා මේ අමාරු මල්ලි කියන්නේ මේ කාලේ ගන්නවා නෑ ඒ පන්තිල් කරලා ඒක එඩිටින් කරන්න Yeah, that's the way you have to start it. Yes. Correct. Yeah, now we know that we have to apply the formula. We know that we have to apply integration by parts, so for which we need a product. And we have to write this as a product. There's only one way, right? There's only one way that we can write it as a product. Hmm? So write it as sec x into sec squared x dx. That's the only way. So sec square into sec x. Now one of these you have to take as u, the other as dv by dx. Again, thinking logically, if you take this as u, you have to differentiate this. Sec x you can differentiate, that will give sec x tan x. And you have to integrate this. You know the integral of this, sec squared x. It is tan x. අනිත් පැත්තට ගත්තොත් you have to differentiate this. 2 sec x into sec x tan x. And you have to integrate this. Integrate කරන්න ගියාම එනවා උඩයට ඒකට කරලා L මොනවාද sec x tan x එකක් කරදරයි. So better we try the other option. Take this as dv by dx, and because you can integrate it easily and you can differentiate this easily. So let u be equal to sec x, dv by dx be equal to sec squared x. Then du by dx is equal to sec x tan x, and v is equal to tan x. So apply the formula. You get on the left it is sec cube x dx equals ub sec x tan x minus v du by dx. This is tan x. Du by dx is sec x tan x dx. On the step you can simplify it. So that will be equal to sec x tan x minus sec x tan squared x dx. Did you come up to this? මොකද උනේ? මේක ආවද ළමයි? Once you apply once the formula once, එතනට ආවා. So can you say how to proceed? ඊළඟට මොකද කරන්නේ? තව විනාඩි 5ක් ගමු ළමයි මේ ගාන ඉවර කරන්න. What do you do next? Any idea? u equals sec x කියලා ආයි දාන්න කියන්නේ සිතුන්ය. ආපස්සට යයි නේද එතකොට යයි. u equals sec x. ඔව් නේද ළමයෝ ආපස්සට ගිහලා ඔක්කොම කැපිලා යන්න පුළුවන්. Any other idea the others abita oh inno ane the Sachin inno Litmal inno but some other idea tens yeah replace yes situmya then kalpana one hondai you can replace tan square by sec square minus 1 let's do so sec x tan x minus integral of sec x into this is replaced by sec squared x minus 1 और एक कौन था then the next step of course after coming this you can expand it and break it into two parts the integral you can break it into two parts expanding it so it will give something like sec x and x minus so this gives plus integral of sec x dx minus integral of sec cube x dx that way what do you see here now yeah, we are trying to find sec cube x. You got it on the other side again. Yes, send it to the left hand side. Translate. So now it will give manufacturing interval 2 integral of sec cube x dx equals sec x tan x plus integral of this will go to the other side and we'll make it 2 integral of sec cube x dx equals sec x tan x plus integral of sec x. Sec x integrate කරන්න ඉතින් අපි අද කතා කරන්නේ නේද? That's something again you should remember, right? There is no other method. Hari Litmal, yeah. Take sec cube x to the other side. Yeah. Agata Hari Litmal. Now to integrate sec x, you should remember that method. You have to multiply and divide by sec x plus tan x. Multiply and divide by sec x into sec x plus tan x divided by sec x plus tan x. පළවෙනි දවසේ හරි දෙවෙනි දවසේ හරි ඉගෙන ගන්න මේක dx. Now in this you have the derivative of the denominator. Derivative of the denominator in the numerator. So it's ln form. Sec x. Sec x gives sec x tan x. Tan x differentiating sec squared x. You have the derivative on top. So it's ln of the denominator. So sec x tan x plus ln mod of sec x plus tan x. So finally we will divide by 2. Sec cube x dx equals the half of everything will be divided by 2. Sec x tan x plus ln mod of sec x plus tan x. Finally plus c. प्लस C लिया नाम तक करन देपा. Yeah, sec x plus tan x. Hari situnya. Yeah, that's the integral of sec x. Ini kira sakra itu makanya. Sodium. මේක ඉවර නම් කියන්න ළමයි. ඉවර නම් කියන්නද? මේ පාඩම ඉවරයි යා. Integration by parts. කියන්න තියෙන ඔක්කොම දේවල් කිව්වා. ඉවර නම් කියන්න. Abita. Finish. What about the others? Finished. Dunya. Hari. එහෙනම් මෙහෙමයි homework වලට මොකද පළවෙනි කාරණේ by now we have covered all the basic methods of integration. Basic methods ඔච්චරයි. So whatever we are going to learn hereafter, right? Ultimately we come to one of these. මෙච්චර දාස් ඉගෙන ගත්ත ටික හොඳටම තියෙනවා නා. මෙතනින් එහාට පාඩම යනකොට, right? So next day we are going to start something different. Integration using a substitute by substitution. ඒවා මොනවද දැම්මත් අන්තිමට මේ මෙච්චර දාස් ඉගෙන ගත්ත ඒවා එකක් එන්නේ. කැරකිලා එන්නේ. හරි? Right. So homework for today's homework, you have to do exercise E. මම මේකට තව එක ගානක් දාන්නද තමයි. Exercise E. It's there are parts up to 11. Part 12 එකක් කියලා ගන්නකො. Say 2x minus part 11 වෙනකන් තියෙන්නේ 12 එක අතින් ලියා ගන්න. 2x minus 1 squared ln 3x කියලා දාන්නකො. ඒක ක්‍රිස්මස් එකට මගේ ගානේ යා. There are 11 parts in exercise E. Add this to that, right? As number 12. 2x minus 1 squared ln 3x. That's for the Christmas. Right. එහෙනම් අපි අදට ඔතනින් නවත්තමු. අනිත් දවසේ පටන් ගන්නවා integration by substitutions. දැන් ළමයි එහෙනම් ඔයගොල්ලෝටම සුදුසුසරණයි. Good night. රිවිෂන් පේපර්ස් දාලා තින්නේ සතියක් ඇතුළත ඒවා කළා මට එවන්න දෙමව්පියෝ කවුරු හරි යතේ වැඩ පිළිවෙල මම ඊයේ පෙරේදා මෙසේජ් එකක් දාලා ඇති සාකච්ඡා කරපු වැඩ පිළිවෙල දෙමව්පියෝ යතේ එවන්න ලබන සෙන්සුරාදාට සාකච්ඡා කරනවා මේ දවස් 3-4ක් ඇතුළත එවුවනම් හොඳයි යා පළවෙනි රිවිෂන් පේපර් එක quadratic equations. Okay, thank you and good night.